Hey, welcome. Series and sequences is the name of our new unit. Of course, I messed that up. It's supposed to be sequences and series, but I always say it backwards. So notes begin with this. Let's see how badly this is. Yeah, love it. Okay. Technically, sequences goes first. We're going to start with a lot of vocab. Put that way, plus matching. Okay, how dare you? Give me your best today about that. All right, we need to start with some vocab. All right, a sequence is merely a set of numbers. And a series, that's their word for adding them all together. Vocab begins. Crinkle, crinkle. So what would it look like? 2, 4, 6, 8 is a sequence. What would the series be? 2 plus 4 plus 6 plus 8. Vocab. First question on the test won't be till after spring break sometime. All right, they're going to ask you about that vocab word series. Remember, that's their word for sum. Yeah. Bless you. More vocab. Thanks. Yeah. Well, 2, 4, 6, 8 stopped. If it stops, it's called finite. And if it don't stop, it should be infinite, but what do they pronounce that? Infinite. I just work here. Okay. So finite and infinite. Don't you love English? Should be finite and infinite. Or finite and infinite. But it's not. Okay. How do you show that it never ended? Do you know this? Go back to 2, 4, 6, 8. Okay. If it doesn't stop, it does this. Okay. And it continues in the same what? The same pattern. The dots mean infinite. Okay. I think 2 more vocab words. Okay, what if it takes this pattern, eyeball it? What is the pattern? What's going on here? What are they doing each time? Adding 2. You add, it's called arithmetic. Yeah. Arithmetic, not arithmetic. Don't you love English? Okay. So when you add the same number, that's what it's called. When you multiply by the same number, the word is geometric. And I'll give you the book definition in red and our definition in green down there, in case you're wondering what's that. For my money, could be the easiest unit of the year. 100% calculator. Formulas you're going to get. Won't get easier. Yeah. So arithmetic, that's easy. Add 2, add 2, add 2. What's going on in the geometric? multiplying by 2, that's our definition. All right, but what does the book definition say? Every pair of consecutive numbers will have the same ratio. So let's say I pick these two. Give me a ratio of 4/2. What is it? Oh, you could do 2/4, it's half, okay. But if we do 4/2, it's 2, whatever. Okay, I'll just stick with yours. 2/4 is a half. Pick any other pair. What's 4/8? A half. What's 8/16? A half. So if you're not sure when you look at it, you can always do that to see if it's geometric. Okay. So give you an example. But okay, when you eyeball this, is it arithmetic? Yes or no? Here's how you try it. What would you add from here to there? 0.5. If we added 0.5 again, this would have been what? 2. So that it's not arithmetic. Okay. And then am I right? If you think in geometric, okay. I don't know. Let's try putting it in the calculator. That's easy one. 1.5 divided by 1. I got that. 1.5. All right. How about these two? I type that in. 2.25. Better get my calculator rolling. So 2.25. Get rid of this. Divided by 1.5. Yeah, so we are multiplying by 1.5, even though it wasn't obvious. Okay, so remember you're allowed to do that. But any two that are next to each other, they should have the same multiplier. Okay. All right, back to definitions. Okay, so now I want to introduce you to the type of problems we're going to see. Let's start slow. Okay. All right, this is my way of saying the rule. Okay. So the rule for this sequence is 8n minus 1. Okay. Why do I use T when the book uses A? Because T stands for term. What do you think N stands for?
Number.
So if I want term number 1, what's it going to say? T1. They use A1. I thought it would make more sense to be a T. All right. So what just changed from here to here? The N became a specifically 1. So guess how you find the first term? Plug in 1 for all n's. Don't strain yourself. What's 8 times 1 minus 1? 7.
Oh.
7 is our first term. Why don't you find P2? What's second term? Plug in a 2. And use calculator if you want, but probably can do this. Okay, plug in a 2. 8 times 2 minus 1 is 15. Keep going. Find me the next 3 terms. T3, T4, T5. Dude, that's huge, 2,000. Hope not. Especially if you're gonna do it here. So giddy up, plug in the 3, what'd you get? 24 minus 1 is 23, all right. Even though you're certainly allowed to plug in 4, plug in 5, take a minute here to eyeball it. Do you see the pattern? Yeah. What is it, arithmetic or geometry? We are doing what each time? Adding 8, so it's arithmetic, and instead of plugging in, why don't you just keep adding 8? So add 8 to this, what do you got? 30, wonderful, and 39. Okay, same answers you would have gotten by plugging in 4 and plugging in 5. Okay, so that's how you create a sequence. Okay, all right, and what's a series? We do what with the sequence? Add them. Okay. So you and your calculator, go ahead and add those together. What's our sum total for the first 5 terms? Under 15, I got up here. Is that okay? All right. So how is that going to be asked of you? Like this. They were clever this time. S stands for sum. Sum or series. All you did was add them together. Okay. So we got a lot of vocab. So keep these notes handy. T for term, S for sum, arithmetic, geometric, finite, infinite. Okay. The one we created up here, finite or infinite? Stopped at 39, so yes, finite. Okay. So I think quiz question might be, I would ask you to describe it. You'd say finite arithmetic. So welcome to series and sequences. There's your first problem. Right. Now, I want to show you another way to do this. Or at least another way that they will present it to you. And it's called sigma notation. The Greek scholars out there. Me neither. Okay. So write this one down. That's what sigma. That's Greek letters.
Of course.
They didn't have internet back then, so they did a lot of math. So. All right, so believe it or not, what you see here is exactly what you just did. Okay, sigma means sum. All right, and what's this guy called? 8n minus 1. What did I call that? The rule. Okay, and these two things here, this is the lower bound and the upper bound. So what you're going to do is you're going to start with this number and plug it in. We already did this. Okay. You plugged in 1, 2, 3, 4, 5. Why'd I stop at 5? Because that was the high number. Okay. So this is just another way of doing what you just did. All right. They'll give you this, and I will have you expand and evaluate. So at least write it down. We've already done it. What was it? We plugged in. We got 7, 15, 23, 31, 39, and you said it added up to 15. Yeah. Definitely putting that on the quiz. And I'll just say expand and evaluate. Okay. And again, sigma means sum or series. Okay. Maybe we need to try one of these. How about if you try tell me what this adds up to when you get done expanding it and evaluating. I guess first question is this: how many terms are you going to have if you start plugging in 3 and stop when you get 6? That's what I would have said. It's 4, right? Plug in 3, 4, 5, 6. So what do we learn from this? It's always one more than it looks. Okay. And the one we just did went 1 to 5. Everyone knows 1 to 5 is 5. But what's 5 minus 1? 4. So it'll always look like 1 less. Remember that. Always one more than it looks like. Okay. So if I gave you this, and I will, how many terms is it? $78, because it looks like what? 77. And it's always one more than it looks. Okay. All right, finish this. Now that we know there are 4 blanks to fill it. Total them up. Does everybody have a calculator? One of those, I want to show you a trick here. Trick, yeah. You can type this whole thing in the calculator. Including that guy. Yeah, oh, you picked a good day to be here. Glad you didn't have testitis like some others. All right, here we go. Plug in a 3. Plug in a 3, what do you get? 5. Plug in a 4. 7. Plug in a 5. 9er. And then finally plug in a 6. The left. Okay. So add them together. 32. Is that what you got? Okay. So that's how you do a sigma notation problem. All right. So trick for you on your calculator. All right. On your quiz, I'm going to ask for this and this. Okay. But on, SAT or whatever. All right. I'll show you how to do this in the calculator. All right. Go to Alpha F2. Who do you see up there at number 2?
I'm singing.
Well, it's sigma summation notation. Let's try it again. Alpha and then window. Okay. And then if you hit number 2, what you're going to see is you can just fill in the blanks. Okay. Pick a letter. How about X instead of N? And where did we start? 3, went to 6. What was the rule? 2N minus 1. If I push enter, it better say 32. Okay. Bad didn't show up late. Trying to catch up with us. Yeah. So that's how you could use calculator to check yourself on our quizzes and tests. Okay. Sigma. All right. So what else? Today's a double day. We postponed the test. Double day. Mm. Yeah. All right, 2 more vocab words, and then I think we can move on to day 2. Converge, diverge. Familiar with these words at all? How about diverge? Wasn't there a book, Divergence, a couple years ago?
No.
Anyone read it?
What?
Does anyone read Divergent?
No.
You got one, you got 2. Yeah, how about my daughter's high school? The whole school read it, including the teachers and the custodians and the principal. And it was the book of the year, or whatever. They had to all read it. They did make a movie eventually.
Yeah.
Yeah. Why would they miss that out? Anyway, what word is in there? What other words start with a DIV? Divide. Not that I would know about hair, but isn't there like a diffuse? Yeah, no. Picture that. Anyway, dividing, you're going from one into many. So I put the up arrow meaning it's going out. That's divergence. Converge or convergent. Okay, when you're going from many to one. Okay, the students converged on the free donuts. There weren't any left because the teachers got to it first. Okay. So what does it look like? Like this. What's happening on the left here? 4, 2, 1, half, going down by less each time, right? And show off for our new arrival. What is this? Arithmetic, geometric, or neither? Definitely not arithmetic because it's not adding. Yeah, well, and remember, I say adding, but you can add a negative. So what would we have added to get from here to here? A -2. What would the next number have been if we added a -2? It would have been 0. So it's not arithmetic. Are we multiplying by the same number? Answer, yes. What are we multiplying by to get from 4 to 2? Half, or 0.5. All right, so let's do this. Multiply by half. Yep. What's half of 2? 1. What's half of 1? So this is called geometric. And the numbers are going down. Okay. How about this guy, arithmetic or geometric? Geometric again. What are we multiplying by this time? 2. And the numbers are getting bigger, bigger, bigger. Okay, so there's your difference between divergent and convergent. Big day. You picked a good day to be here. Right. Okay, now, more vocab. Oh my goodness. Okay. This will refer to the rules, a recursive rule and an explicit rule. Recursive rule Well, use the previous term. Well, if the term you got is t sub n, then what's the one before it? T sub n minus one. That means previous term. Okay, and the explicit rules are the ones you've already seen. 8n minus 1, that's an explicit rule. Okay. So we're going to do a sample here. In fact, let's do old 2, 4, 6, 8. Let's do that one. All right, so here's what you're given, 2, 4, 6, 8. And I want these two things. An explicit rule, and then we'll do a recursive rule. All right, when you eyeballed this, you thought what? We're doing what each time? Adding 2. All right. Don't write this down because it's wrong. Why is it wrong? Put in 1. What do you get for your first term? 3. I'm booked already. What are we going to do? Cry?
Yes.
Anybody know it? What is the rule instead of n plus 2? Say it again. I think someone has it. 2n. It is 2n. And we're just guessing and checking. That will end in about a minute. But does this work? Plug in a 1.
Yeah.
You get 2. Plug in a 2. What do you get? 4. This works. Okay. So this is called the explicit rule, 2n. All right. And then the other one, the recursive rule, you're going to always start with this. And then you're just going to tell me what happened. Okay. So here we go. Tn recursive. You're always going to start with that. And then you already did tell me what did happen over here. What were we doing every time? Adding 2. Okay. So this is the recursive rule. This is the explicit rule. Make sure you understand this. Okay. Which term number is that guy? No, which term number? Term 2. Second one in line. Okay. So plug in a 2 right here. What does it now say? Term 2 equals who? What's T2 minus 1? Term 1. And then add 2. Is that what happened? Term 1, add 2. Okay. How could you find term 3? Start with term what? 2 and add 2. So it always uses the 1 before it. All right, who's not pictured after 8 over there? Term 5. Okay, what if plug in a 5? Find term 5, plug it in here, and then all you're doing is what? Adding 2 to term 4, which is how much? 10. Now I'm doing it with easy numbers so that you could have done it in your head. You didn't need a formula to tell me it was 2, 4, 6, 8, 10. Okay. How about this? Plug in 5 right there. What's the 5th term if you use this rule? 10. Okay. So that's where we are heading. All right. Except for that guess and check. That was good over there. All right, but we don't want to have to play guess and check anymore. That's no good. You like guess and check? Don't do that. Okay, all right, so that was 9-1. Now we're going straight arithmetic for the rest of the day. And this is good because we ain't gonna have to play guess and check anymore. I'm gonna give you your first formulas for arithmetic series and sequences. See, I told you I'd say it backwards. Sequences and series. These are Wednesdays that's coming at you. Despite all our hieroglyphics so far, this is an easy chapter. It is. Okay. Any of that at home. All right. So here it is. Star these, box them, highlight them. Here are, oh, that's 2, 4, 6. Here are your first two rules and formulas, I guess. The explicit rule and the sum for arithmetic. Right? These that. What I say, I was going to give you all the formulas. Yeah, let me cipher these. Okay. What does TN stand for? Term number. And book's gonna put what instead of a T? Stupid book. A sub N. Just deal with it. Okay. T1 is who? Term 1. Okay, first term. And you said was number. And D is the only newbie here. This is called the common difference. Common difference. Better known as what did you add? Okay, so when you say we added 2, that's D. And S stands for something. So here we go. We're going to use these formulas to do 2 things. To find the rule for 2, 4, 6, 8. Then we'll do a you try. I think I found it. Fast forwarding. All right. This is what you're going to have to do. Find me a recursive rule and an explicit rule for something like 2, 4, 6, 8. We've already done this, but so you don't have to write it down, but so that you see it again. Okay. The recursive is the one that always starts with what? T n minus 1. Always. This is always here. Okay. And then what happened each time? Boom, plus 2. So that's your recursive rule. How do you lose points here? There's only one way. This needs to be where? It's a sub number, okay? So don't write Pn minus one. Like that, don't do it. Make sure the n minus one is the lowest. And now, we said this was 2n, but you did it by guess and check. Now I want us to actually use this. Yeah, so here we go. Pn equals, what do we have first? P1 is what? 2 plus n minus 1. What was common difference? 2. Simplify this with me. What do we get? 2 plus what? 2 plus 2n, and then what? Minus 2, and what does that end up? Okay, so no longer do you have to play guess and check over there. Okay, so how about you try, and you'll give me recursive and explicit. I think one will be enough. We shall see. Okay. It's a little tricky. All right, write this one down. 5, 1, -3, dot, dot, dot. I need recursive rule and explicit rule. Okay, for a recursive rule, remember, what does it always start with? Tn minus 1, and then you're supposed to tell me what happened. So eyeball it. What happened? You say -4. You're not wrong. Okay, so I will accept that for full credit. However, hear me now, most important 5 seconds of the lesson. It'll always be, what did you add? Yeah, but when we do sum, or actually when we do explicit rule, what we added is what's going to be important. So yes, I'm kind of doing this with you. I'll give you another one. All right, let's fill this one in. First term is 5. Okay, so we got 5 plus n minus 1. And here it is. If you put a 4, you're cooked. What did we add? A -4. Okay, finish that. Simplify. Parentheses are important. Because we were adding 2. What do we add in this time? -4. Yeah. You go. That worked with me. We got 5. What? Distribute this. -4n and plus 4 makes -4n plus 9. Okay. All right. So check yourself. P2, plug in a 2. What is that? 9 and a -8 make 1. Okay. So it did work. Okay. But what about a poor soul that put in +4 because they said we were subtracting 4? Let's see what happened to them. Okay. If they put in a +4 here, what was their rule? 4n plus 1. Does that work?
No,
plug in a 2, and what do they think the second term is?
no.
None. Okay, so most important part of today is remembering what did you add? Even if it's a negative. Solid. And I said I'd give you a actual you try that I didn't do for it. Let's do that. Five, 15, 25. Okay. All right, so once again, try to do the recursive and the explicit. Use calculator if you need, but simplify. So distribute it. And then. And you distribute it. Oh,
I never know.
yeah. All right, pretty good. Okay, this one could be the easiest one on the quiz. Start with 10 minus 1. Tell me what happened to get from here to here, here to here. Added 10. And again, beware, you could add a negative number. All right, so that's that. Yeah. And over here, we're plugging in for the explicit rule. What's first term? 5. So 5 goes there. 5 plus n minus 1 doesn't get anything. And then what are we adding each time? This time 10. Okay. So this is going to turn into what? 10
And
n minus 10. And when you gather them up, you got 10 n's. And then what's 5 minus 10? So this is your explicit rule. Now, I don't think I've made this point well enough. This is important. This is huge. What if I ask you for the 100th term right now? What is it? You should know it in like seconds without a calculator. Put in a 10
oh,
or did it say 100? Put in 100. What's 100 times 10? 1,000. 1,000 minus 5 is 995. Okay, someone out there is going to be on the test going, can I have more paper? Okay, they're adding 10 repeatedly 100 times. Okay, no, plug it in. Okay. Now, why is this one, bless its heart, less valuable? What do you have to have before you can find the 100th term? Which term? You gotta have the 99th term. And you don't have the 99th term till you have the 98th. So this one less valuable. All right, but the explicit rule, huge. Okay. All right. They got that. Heard the message loud and clear. All right, so a couple more that are arithmetic specific. Double day. Too easy. Too easy. All right, let's do your first sum problem. Okay, write this one down. Sigma means sum. And just for vocab, this is the rule. This is the lower bound. This is the upper bound. You will never be asked to identify them. But in case you wanted to know. All right. So sigma means sum. So I now write this. And how many numbers are we finding the sum of? From 1 to 10 is 10. So that goes here. Okay. Now, first time, break out the S formula that you copied to start the day. I believe it was this guy. N over 2 parentheses T1 plus T. Okay. Where'd I cover? You copied it down and it's going to be on posters all unit long. Okay. So decipher this with me. What just changed? N has now become what? So make all the N's into 10. And now let's get to work on this. What's this? Okay, so 5. Who's this? You don't know till you plug in the first number. So let's do that. What is the first term? 5. Okay, so we got 5 times 5 plus 10th term. Guess how you find the 10th term? Plug in the last number. Who that?
32.
32. All right, and feel free to use calculator. What is 5 times 5 plus 30? Big number is the answer. No, what is the answer? 185?
Right.
Is that what you said?
Yeah.
Yeah. What did we say? You could plug this whole thing into the calculator to get that answer, including the sigma. Okay. But I wanted you to see what it's like to use the formula. All right, our last two of the day, off my personal favorite. This one's called the bunny hop problem. Might as well be real. The book is going to give you this. Book is going to give you this. I want you to draw that. Third term is 10, so it's blank, blank 10. And blank, blank 28 because the sixth term is 20. And so when you get this, it's the bunny hop problem. All right. Here we are. Easter time. Let's talk bunny hops. Okay. So what do they have to tell you? And they've got to tell you arithmetic or geometry. Today, all day, arithmetic. Okay. And you know what? Let's change this. I want you to find T1. Not TN, but T1. Any suggestions? How could we find the first term if they gave us the third and the sixth and told us arithmetic? Let's do this. How far is it from 10 to 28? 8. Right? Yeah. How'd you get that number? Subtract. Right? 28 minus 10. Okay, so step 1, subtract. And here we go. How many bunny hops is it from 10 to 28? 3 bunny hops. And what's bunny doing each time if it's arithmetic? It's adding D. How many times? So what's each one gotta be? 6. So each bunny hop is plus 6. Which means show off if you want. What's this number? 16. And what's the next one? 22. And did we do it right? Yeah, 28. But I want you to go backwards, right? So instead of bunny hopping plus 6 there, now we're going to go backwards.
Nice.
Go ahead, find me term 1. Bunny hop problem. Going backwards 6. What's T2? 4 and subtract 6, and we got our answer. Negative 2 is term 1 or A1 in the book. Okay, star that one. And the last one of the day. This will be worthy of your high intelligence. Yes, so they gave you some of the first 17 terms and the 17th term. They want D. Okay. How to begin? Well, since we're in the arithmetic section, we're using the arithmetic formulas, but what one letter up there told you it was going to be arithmetic? This one. Okay. B is in what formula?
Oh, okay.
So I'm going to roll out the formula that had D in it, which was this one, right? So step 1, write that guy. What other letter hasn't shown up yet in green?
T1.
T1. T17. True, true. How about an S? Yeah. What formula do we have with an S in it? This one. So this is how you do this. This will be the hardest one of the unit. Okay, so we got 2 formulas. How about we start filling them in? Take a wild guess. What's N every time you see it? for this problem? 17. Start filling it in. Step 1 done. Now some substitutions. Do we have T17?
Yes.
We sure do. Plug it in. We have S17.
Yeah.
Plug it in. Right over here, do we have D? No, that's what they wanted us to find. But let's go ahead and fill this in. T17 is negative 13. T1 unknown, and I'm gonna call this what here? 16. Okay. So all you did was roll out the formulas, fill them in, and now we're down to the greens. Which of the two equations has to be done first? This one over here, because how many unknowns are in this one? One. How many unknowns are here? Too many. Okay, so why don't you solve for T1 over here? Okay. Scary moment here. This is algebra 1. Solve for T1. You can use your calculator. 2 steps. That's for me. What's up? T17. Because all the M's turned into 17. Highly recommend calculator. Highly recommend. You didn't have to sign in. Sorry, didn't even register while you were doing that. Okay, and did you have your 2 incompletes finished? You could write them next time if you didn't, but if you have more. Sheet L1 and the book. Yeah, work with me over here. What do I gotta do to get T1 by itself? Who's gotta move first?
Yeah, 7.
Oh, 187 is already over there.
7 divided by 2.
17 divided by 2. Yeah, some of you called this, what, 8.5? And then did what to get it over there? Divide. Okay. But since you're a high flying honors group, what fraction could I multiply to make it go away? How about the reciprocal? 2. Right? See the 2's and the 17's? And believe it or not, you're going to get a nice whole number here. What is 2 times 187 divided by 17?
26,
What?
22.
22. That's how you know you did it. You're like, wow, that turned into 22. Add your 13, and what is first term?
35.
Yeah. First term is 35. Is that what they asked for? Of course not. Okay, what did they ask for? D. So you're gonna hand carry 35 over here and plug it in right there. All right, last stop here today, solve for D. Won't be a positive number, but it will be a nice integer, solid, no decimals needed. Star this one like this. Crazy. Blurt it out when you get it. That's correct. So what did you do first? What's the furthest thing away from D? 35, move it. Got this. And what's the last step to get rid of 16? Divide, and you are correct. D equals -3. Do initial that. That was a work of art. Okay. So welcome to series and sequences. Won't be on the test. Okay. Which is next time. Okay. Very good job today. And you should be full because that was a double helping. Okay. All right. Good job.